Let's talk about something you probably never think about, but that protects you every single day, the science that keeps your medicine safe. It all comes down to a single, powerful number, a hidden calculation that stands between you and potential harm. Today, we're going to follow the journey of that number, from a lab all the way to the pill you trust.
Look, every time you take a pill, you're placing your trust in this huge system of safety checks. And that whole system has to answer one really tough question. When it comes to the tiny, unavoidable impurities in every single medicine, how do you decide what's safe enough?
Here's the reality check. Making something 100% pure is, well, practically impossible on a massive industrial scale. You're always going to have something else in there, whether it's a tiny bit of residue from a cleaning agent or just a byproduct of a chemical reaction.
So what do? You can't have zero impurities. What you need is a line in the sand, a scientifically proven threshold, a number that tells manufacturers, okay, below this level, it's totally fine for a lifetime of exposure. And that is our mission today, to find out how they calculate that one critical number.
So where does this whole journey even begin? It all starts in a laboratory, with scientists who are carefully searching for a baseline, a dose so low that it causes absolutely no harm at all.
And that baseline has a name. It's called the NOAEL. That stands for No Observed Adverse Effect Level. Just think of it as the scientific starting line. In lab studies, which are usually done with animals, it's the absolute highest dose of a substance you can give where, nothing bad happens, no detectable negative effects. That's our perfect starting point.
Now, the NOAEL is the gold standard. But what if scientists just can't find a dose with zero effects? Well, then they have to use the backup plan, the LOAEL, or Lowest Observed Adverse Effect Level. And this is exactly what it sounds like. It's the smallest dose where they did see some kind of harmful effect. Using the LOAEL is kind of like a red flag. It means we have to be even more careful and build an even bigger safety net later on.
Okay, so we have our starting point from the lab. But let's be real, a number from a study on rats isn't enough to protect you, is it? Or your kids, or an elderly relative? So how do we translate that lab data to protect every single person who might take this medicine? Well, we build a safety net.
And this is where the real scientific rigor kicks in. This is not guesswork, it's not a gut feeling, it is a methodical, careful calculation that uses up to 5 different adjustment factors to bridge that gap between a controlled lab study and the messy, complex real world.
Each of these factors adds another layer to our safety net. F1 is for the big jump between animals and humans. F2 is absolutely critical. It accounts for all the variations between people, to protect the most vulnerable among us. F3 adds an extra buffer if the data comes from a short-term study. F4 is for the really nasty stuff, the most severe health risks. And F5, that's our extra cautious layer we only use when we had to start with a low EL instead of a no EL.
All right, we've got our starting dose from the lab, and we've got our safety factors. Now it's time for the main event. We're going to put all these pieces together and calculate that final, safe, daily limit. Let's walk through a quick example so you can see how this works. Let's say an impurity has an NOEL of 50 milligrams per kilogram per day, found in a rat study. We'll use a standard patient weight of 50 kilograms. And for our safety net, the scientists have decided to apply 3 factors. F1 for animal to human, F2 for human variation, and F4 because this particular impurity has some severe toxic effects.
Now, the formula might look a little intimidating, but it's really just 3 simple steps. First, we figure out the total dose for our standard person. Second, we multiply our chosen safety factors together to see how big our safety net is. And third, we just divide the dose by that total safety factor. Let's do it.
So let's start with step 2, which is calculating the total safety factor. The science gives us standard values for these. So F1, the rat-to-human factor, is typically a 5. F2 for human variability is a 10. And F4 for severe toxicity, we'll call it a 2. You multiply them together, 5 times 10 times 2 gives you a total safety factor of 100. That means our final limit is going to be 100 times safer than what the lab data suggested.
Now let's pop back to step 1, the unadjusted dose. We just take our NOAEL of 50 milligrams per kilogram and multiply it by our 50 kilogram person. That gives us 2,500 milligrams. So that's our raw number, before we apply that powerful 100 times safety net we just calculated.
And now for the final step, the end of our journey. We take that unadjusted dose, 2,500 milligrams, and we divide it by our massive safety factor of 100. The result? 25 milligrams per day. This is it. This is our number. It's called the Permissible Daily Exposure, or PDE, and it means a person could be exposed to 25 milligrams of this substance every single day of their life with no expected harm.
So we have our number, 25 milligrams per day. That's great, but so what? What happens now? How does this number actually get off the spreadsheet and into the real world to make your medicines safer?
Well, this one number has two incredibly important jobs. First up, cleaning validation. It tells the factories the exact level of clean their equipment needs to be, making sure no dangerous gunk carries over to the next batch of medicine. And second, it sets the official impurity limit for the final pill, guaranteeing that every single dose you take is safely below that lifetime threshold.
And let's just be crystal clear about the stakes here. This calculation, this whole scientific journey we just followed, it's what stands between a safe, effective medicine and a potentially harmful, contaminated one. It is the invisible backbone of patient safety.
And you should know, this isn't just a company deciding to be extra careful. Global health authorities have created mandatory guidelines that require these safety limits to be calculated and followed to the letter. This whole process, it's a non-negotiable part of making medicine anywhere on Earth.
So the next time you open a bottle of medicine, just take a second to remember the journey of the number that's protecting you. A number born in a lab, strengthened by a safety net, and calculated with incredible care. It really makes you wonder, doesn't it? What other hidden calculations like this one are out there, quietly keeping our world safe?